Hello sir, I'm Tanawat Unsiwilai. My student ID is 64303400058. Today I'm gonna representing you about the final project that I created the automation system production line, and we have two robots IRB 1200 to picking and press by sorting the product. I'm gonna show you on the real program. So the real program is I can click on the simulation. On the left hand you can see the real work of by myself that I create by myself, and on the right hand you can see the signal analyzer that I show you the total current of this motor use, the entire of this robot, these two robots use. So you can see the graph is like a pulse, and we have the speed to show you on the signal analyzer, the power and the speed, and another consumption we can show on the signal analyzer. And the right next we can see the simulation stop to counting the timer of the working time. So as you can see, the timing of this working is like around 53 seconds per one piece. And you can see you can use with another piece, but this is just a simple that I can show you on the simulation, just a per piece. In each piece 53 seconds of work, and this is overall of my work. You can see we have two IRB, we have the conveyor, we have the power rate, we have the work object to show you, and then I can show you on the flex panel controller by we can jogging it. When we setting up the program of robot, we can use two ways. First way, we can use teach panel to teach it and create new work object, create new part, new target, and setting it, and it's going to generate this code like this. And another way, we can use the coordinate system to teach instruction of robot, teach robot part, and create a new target, and then gonna generate code automatically. You can use on the easy way that you can. In your convenience, you can use every way that on your convenience. But this I can show you on the jogging process. Just show you some code and explaining the code and show you how to jogging. First, we have to enable the motor onto the manual, and then we can jogging like this. We can jogging, and we can create a new work object, new target, and set it into the teach instruction. It's gonna generate as the code. And then you can see on the tuition that it have a calibration, input and output, program editor that we can editing the program, and we can create a input and output signal here, as you can create a working object. But for this project I create by the coordinate system. Yeah, right here as you can see the robot target to data, the working object data that I've created to use with this project. And then you can see the jogging. You can select the joint that you want to jog. So in this case, I have two robots. So this is a code on the string object type. I create that one is orange, two is blue, three is some coin. This is a code that generates from the coordinate system, path, target, and station logic. That's generate as the code here. So you can see object type that they create on three cases in each because we have the three object. Case 1 red, case 2 blue, case 3 is orange. Okay, let's move to another thing. So the signal set up, and we have a coordinate system right here. Okay, I can show you the our component. IRV2, we have a station element and the controller that we have created before. So I'm gonna show you some here. Two work object. Okay, I'm gonna show you some part, and you can see the coordinate on the robot right here. Okay, let's move to. Okay, this is a part socket that picking for picking up into the for work object into the conveyor by first robot. I'm gonna show you component on the Word documentary what I have to into to make this project until then we have gripper. We have some gripper right here, and then this is a module on our gripper to make a coordinate. And we have some gripper right here. So this is a work object that I created from the and that. Alright. As you can see, architecture, we have a lot of architecture. Because the architecture we have to setting up into the gripper. So this controller. Okay, let's deep into the detail. I'm gonna tell you the some component and station logic, how to use it, and show you the station logic on the next part that I'm gonna show you. Wait for that. Alright, let's get back. As I showed you on the real programming, real simulation. So I'm gonna deep in detail before we go to the final step. I'm gonna show you the deep on detail of robot sorting production line is my project. Deep on detail on the automation component, robot component, and each specification. So first thing, as you can already saw it on the real program, is a working space that we have a table. So the objective is sorting robot, sorting the work object by sensor detect the different type of object and grab it on the conveyor on the production line. And we have a work object on the three color red, blue, and orange. And we have a robot IRB 1200. So the type of robot, and this is the specification of this robot. And we have working range around 700 by 1500. So the workflow, and as you can see, we're gonna picking up the work object and send it into the conveyor, and another robot gonna pick and place it into the pallets. So the operation make a robot sorting a color needed and pick and place into the pallet and to send it to the conveyor to move the object to the production line, and another robot pick and place it to the final production line. So the automation component, the human is send the production line to the line, and conveyor send a work object, and we have two robots required. So the work object is 3 type color and is 30 centimeter by 30 centimeter. And we have an effector gripper, is a vacuum gripper. And we first thing, as I showed you, we have to define part and target, choose instruction, or we can use the controller to jogging, teach pendant, or we can use the choose instruction, part and target by the coordinate system. As you can see on this picture, yeah, like this. And we have a sequence code. On the some sequence code, we can give a detail like we can create from the prod and target, and we can use the simulation logic, station logic to use it. On the case 0 is on the red one to pick and place this. Our object type 0 is mean the red one, the first object, and we can apply it onto the conveyor coordinate system. If it's true, it's gonna pick up. If it's false, it's gonna pull it out on the real work object, like on the case coding sequence. So we can deep on detail into the station logic. First thing, we have to define the controller. We use two robots but one controller. We use just only one controller. So we do the reset. We have to create a detector and attachor to attach the work object into the vacuum gripper. So when they do a trash one, it's like a first work object is on the sensor. We force the attachor to put the work object into the gripper on this line. Yeah, and you can see on the parent we use with the gripper and French we use with gripper. And shy we use on the sequence code tab A is like force it into true, and it's gonna pick and place the work object. And attach AP2 is the same but different work object. A first object to a second object and third object. So we have the plane sensor to detecting the axis. It's used like a wheel sensor, but it's like a plane of the line sensor. When the work object moves through it on the conveyor, it's gonna force another robot to being pick and place it. And we can set up the S1 and S2 on the origin coordinate system. And on another line, we can use the positioner AP2. It's like a plane sensor too, but it's like a positioner, or we can, when the work object is on the ground, we can use positioner to locking to setting the position that we want to pick and place. And another type, we can pull it out on the position coordinate system that we want. So first I set it on the 200 and 500, and on the right hand is detector. It's like a attachor, but on the detector to put the work object out, and have to add the attach in every coordinate system of an effector gripper in each component, and work object to use in rule code in each type of object detector. right? And we can gonna show you on the real work of real simulation next.